we need some mathematical tool for the generating functions. How do we get the coefficient of infinite series take power n? Okay, that's it. Okay, so here this one is the derivation. So I'm not going to test the how you go from here to here in exam. I'm just here to show you why this is true. So first, okay, we need to know this. So what it is? This is what? Geometric series. So you take 1 plus x squared plus up to whatever. In the end is infinity. So you are assuming x is smaller than 1. So this thing won't diverge. So you keep adding this. So you get this symbol. This gives you 1 over 1 minus x. And then what? Now I'm going to do is differentiate. Okay, I write like this. Okay, so now I'm going to write d dx. If I take this, so basically it's just the k go here and then k minus 1, right? And then for this one, okay, I'm going to do the chain rule. So first of all, there's a minus 1, right? So I have a minus 1 here. And then this becomes minus 2. And then this gives me negative 1. And the negative 1 will cancel with this negative 1. Therefore, so this is what happens if I do ddx. So now suppose I do again. That means I want this. So on the left hand side, it will be k minus 1, k. Okay? K minus 2. On the right hand side, I will have a negative 2. Okay? Negative 3. And then d negative x dx. It gives me negative 1, which cancel with the negative. I have a 2, right? So I will have a 2. So I will have a 2 here. Right? And now you see, I will get what? I will get k minus 1. And then what happened? The next term. Next term will be k minus 1, k minus 2. And then I have x, k minus 3. And this guy I will have 3, 2, and then 1 minus x, negative 4, and so on. So now you see what I will have. If I do it many times, I will get this. So it will be k minus 1, k minus 1, k minus 2, k minus 2, k minus 3, and so on until I stop. Okay? And then here I will have 3, 2, and then next one will be 4, 5. If I keep doing it to n minus 1, so then I will have n minus 1 factorial. Okay? And then on the power I will have negative n. Okay? And then similarly for this I will stop at n minus 1. So I will stop at n minus 1. These two combined will give me the 2. Okay? So that's how you get this one. Okay? Then what's next? Now I have this one on the top. So what I'm going to do is I'm going to let r as k minus n plus 1. So if I let r as k minus n plus 1, I write k as a function of r. That means k is r plus n minus 1. So basically I move the n here and I move the 1 there. I get this. So now all the k, okay, all the k, I have highlighted, okay, I have highlighted all the k, will become this r plus n minus 1. So the first green term will become this guy. The second green term will be what? The same thing, r plus n minus 1. Okay, the second term, there's a minus 1 already, there's a minus 1 here. This minus 1 and the minus 1 give me minus 2, okay? And then the second term, this guy, there's a minus 2 here. This minus 2 together with the minus 1 give me minus 3, okay? And so on. And then in the end, here, what is this? K is r plus n minus 1. This will give me r plus n minus 1. Okay, but I have a minus n plus 1. So basically just cancel out everything. And I get r. Okay, so basically I now have this guy. Okay, what about this side? This side has nothing to do with r and k. So just keep it. So this side I just keep it. Okay, then what's next? Now I have this thing. Okay, I almost forgot. This k also become r plus n minus 1. Okay. So this guy also have r plus n minus 1. This part is n minus 1, so I keep it. Okay? So I have now this guy. And then what's next? Well, this part have n minus 1, this part have n minus 1, so I can remove them. I remove them. Then I get start from r equal to 0. So this is how I get from here. And then what about the other part? Well, if you look at here, it is what? It's a decreasing factorial, but it stops at r plus 1. So what I'm going to do, I'm going to complete it by multiplying r factorial, and then but I have to divide r factorial. So that's what I get from here. And once I complete this with r factorial, the green part, okay, on the top, will give me this guy, because I just complete everything with a factorial, okay? And then I put the r factorial in the bottom, okay? What's next? I have this thing. Don't forget everything here, no change, it's the same thing, okay? So now I have this one. Then what's next? Okay, so up, we are now at here, So we have an n plus 1, right? N minus 1, so I can divide this guy, move to here. So if I divide this guy to other side, here become 1, but the n minus 1 go here. Okay, what is this? This is r plus n minus 1, choose r. Okay, so this is r plus n minus 1, choose r. Okay, and then what is it? xr. Okay, so now we look at this part. Okay, so first we have 1 plus x squared plus give us 1 over 1 minus x. So now if I have an n here, it will be n here, right? Which is exactly why I have this. Okay, then we have this equal to this, and since this part is this part, and the green is the green, then we have the box. That is 1 plus x squared plus to infinity power n can be written down in a binomial expansion in this funny form. So what's the application? For example, what's the coefficient of x22 in this expression? Well, actually we know that it will be 1 because everything here is just 1. Coefficient is just 1. But it will be more interesting. What about this one? 1 plus x squared up to the power infinity, but the whole thing power 8. What's the coefficient of x22? It will be this. Okay, which gives us this number. And what is this actually? This looks like the following. Okay, this looks like, what is this? N choose R allowing repetition. N choose R allowing repetition. Okay, this is exactly the same thing. Okay, N choose R allowing repetition. Okay, so now we have this box, so we can use it for application. So for example, I want to find the power x22 in this expression. So everything here has an x, so I can factor it out. So I will have x 1 plus x squared plus so on, the whole thing power 3. The whole thing power 3 is the same as I put it power 3 and I put it power 3. And then the coefficient of x22 of this guy is the same as I don't care about this guy and I just care about x19 if I remove this x power 3. Okay, so that is this thing. Okay, so how do I find this thing? Make use of the box. So the coefficient of x19, it will be this guy, which is basically I plug in what's the, okay, so what's the n here? The n here is 3. So n is 3 minus 1, 3 minus 1. What's the r here? The r here will be the power of the x. My r is 19. So I put in r is 19. It is, which gives me 210. Or we can actually try to do a binomial expansion. So here is another way. So suppose I have this. Now what I'm going to do is I have minus 1 and plus 1. So this is I create from thin air. I create something from thin air. I create 1, so I have to subtract it back. Otherwise, it's not equal. And once I create it, then what's next? I put a bracket. So that, what is this bracketed term? This bracketed term I treat as b, and I treat this as my a. And now I'm going to do what? Binomial expansion. So this first step is I'm doing binomial expansion of this thing. And why I'm doing binomial expansion? Because this is only power 3. Power 3 binomial expansion should be easy. Okay, so I expand like this. I just copy this guy here and I copy this guy here. Then what's next? I just write down the binomial expansion. So binomial expansion up to power 3. There are 4 terms. 0, 1, 2, 3. Then I have all these 4 terms. Then let's look at them one by one. So for the first guy, this is basically just 1. Okay, this is just a number, negative 1. And then what this is? Power 0. So they are all gone. Just 1. This one, okay, give us 3. This one is 3 minus 1 is 2. So negative number, even power is 1. So gone. This one is just the same thing. I copy it. So we get this guy. This guy is also 3. This is odd number. So negative. This is the same thing I copy. This guy is 1. This guy is even power. So gone. This is copy. So I have this thing. So now I want the x to the power 22 of the whole thing. So this guy does not contain any x. So 0. This guy will contain what? There will be x22 somewhere here, multiplied by 3. So there will be 3, okay? Or if I use the formula, I can use the formula. It will give me this. So what is this? It is 22 plus 1 minus 1. What's the 1? 1 is the n here. The n here is 1. So this is the n. And therefore, I will have 22, choose 22, one way. So that means 3. So this guy corresponds to this guy. And then for this guy, I will have the same thing. 22 plus 2 minus 1, choose 22. Okay, and then lastly, this guy, it will be 22 plus 3 minus 1, choose 22. I will get this, and if you calculate it out, it will be 210, which is the same as this one. So this is an example. How do you make use of this? This becomes very useful when we're dealing with generating function later.